Thank you, Don. Yes, so it's the first one for me on these multi-project updates, and very excited to start with it. So let's start with, I will just give you like a brief update of all the things that happened in the project and where we with releases and with features and so on. So first, like a couple of like events updates. The Pulsar Summit will be next month in June 16th and 17th. So this is the Pulsar Summit for North America. And there is a new website that has been gone live this week, and there is also the updated schedule with all the talks. And so this is already live and has been published. And you can register. The website is like NA2021, pulsarsummit.org. So please go register now. So it's 1 month away, and there are really a lot of interesting talks there. In addition to Pulsar Summit, we did the Pulsar Hackathon this month. So this was like last week on May 6th and 7th. And the winners will be announced at the next Pulsar Summit. So next month we'll be announcing the winners for the hackathon. It was a very good participation. So there were like 40 people that participated into the hackathon, and they grouped into 11 teams. So there were like different kinds of teams. Some teams were like more like from a single company. There were like teams from Flipkart and China Mobile that were like, and then there were like other that groups in the open source channels. They formed like cross company teams to work on these hacks. So finally, so there were like 11 teams that they submitted their own hack. So the review is going to start soon. I'm on the panel, so I'm very excited to look at all these projects that had been done over these couple of days. I know some of the ideas, and they're like very cool. So I'm really look forward to review all of them. And yes, and the winner will be announced at the Pulsar Summit. So if you haven't participated in the hackathon, I would recommend to look at the in the Pulsar Summit when all these projects will be revealed, because there are always like very interesting ideas. And hopefully many of this stuff will be make it into the production codes. That's always the hope. After these events, more like on the Pulsar project news, there are like a few releases that are happening right now. There is the Pulsar 272. These are patch release. There are like several changes from like 76 from 2001. Most of it, and more important, like 21 bugs fixed, and other like are like smaller improvements and like fixes on the build and so on. So there's like a stability release. There are also security fixes that dependencies with the security vulnerabilities that have been addressed and fixed into this patch release. So everyone is recommended to upgrade to 272. There is really not of risk involved into this patch release. And so it is being voted right now. Therefore, it could be officially released in the next one or 2 days. At the same time, there is also like a new Pulsar Go client release 05 that is being voted as well. And there are few bug fixes as well, a few like resources, handling of some of the resources. And one of the most annoying build issues was with the Z standard dependency that it was preventing multiple people from building the 04 tag. So that should be fixed in 05. that shouldn't block a lot of people. And on more like minor release with a lot of features. So we're still working on Pulsar 2.8. Ideally, it was scheduled to be released at the end of April, but we decided to work a bit more on it because they're like we have several features that we really want to get in, and we want to make sure that they are like ready, stable, tested, documented. All the operability, the monitoring, it is in place and at production quality level. So we're still like finalizing on the testing and documentation on some of the features, and but we can break it down into. There's like a lot of new stuff coming into 2.8. So the biggest one is transaction support. So transaction was already there in 2.7, but it was like really like not an by default. There were several things missing there. With 2.8, we aim to get the full set of capabilities and to basically kind of like mark these as a GA kind of feature. So transaction, yeah, it is where the most of the testing and the focus is for the release. We really want to make that happening very soon. So once we are confident that we can call it done and stable, then that will be the 2.8 will be released. So this is the main thing that had in the release. We just really want to make this right. Other features that went in already like in master, but that will get released into the 2.8 are like the exclusive producer. This is a new feature that you can basically mark a producer to be the exclusive one publishing on a topic. It sounds a bit boring, but really what enables is to have the fencing capability on a topic. And with that, you can basically ensure that no data for other producer can be written. So you can basically have full linearizability on the data that gets written into a topic. And you can build like things like leader election on top of the topic. So they really like more distributed system feature that you can build into your application without, for example, like using BookKeeper. You could just use that through Pulsar. There is a package management service in which basically there's a way to control what are a better API to control like the function code and the connectors code, how they're submitted, how they're downloaded, and so on. We introduced the client memory limit. I will talk a bit more on it. I have more to expand. And there's also ongoing work on the Blackboard metadata interface. This will probably not get completed fully into 2.8, but the idea is that we want to make that it's an ongoing work. It's like a PIP 45, and yeah, it's kind of like a long-term goal to have independence of the metadata store and centralize all the access to the metadata store to a single interface. So bulk of the work has already happened, will be in 2.8. This is not something that is visible to user, but it's kind of like laying the foundation to have cooler features in 2.9. For example, like we could have like a different metadata store being supported, or like even like an internal implementation of it. So this is just kind of like internal housekeeping at this point, but that will be enable better stuff later. Broker estimate metadata. This is another change that went in, and basically like it allows the brokers to add metadata on the messages, basically append at the end of the messages some custom metadata, and that opens up various possibilities. Like, for example, like one of them would be to have like monotonic increase in timestamps that's set by the broker, so that we can use those instead of relying on timestamps that are signed by producer, and so that we can make sure that the timestamp view always goes up and never goes back in time. there's a streaming dispatcher that improves the way that the data is being streamed from bookkeepers to consumer. So instead of relying on batches, it's kind of like a alternative dispatcher implementation that you can use so that it will basically be more proactive in fetching data while it is being pushed to consumer. And finally, there is like a way to get the applied topic policy. So one of the things that were like a bit difficult was that we have different levels in the system in which you can configure what kind of policies apply to a topic in different ways. There are namespace policies, there are topic policies, there are broker policies, there are like system-wide policies that can be overridden in BookKeeper. So there are a bunch of ways to configure the policy for a topic, and they can apply at different levels in a hierarchy. At the same time, like you wouldn't know what which one is getting applied. So am I getting the default for the system, or is getting overwritten somewhere, and so on. So it's kind of like you can get like, okay, for my topic, what are the policies that are getting updated? So it kind of simplifies this discovery of what applies to my topic. And so yeah, this is like all the stuff that is. I mean, it's a small subset. I'm just picking some of the items that will be in the 2.8. There is a lot of more improvements. Also, like in working better with the new version of Java and so on. So there will be a really exciting release with a lot of improvements, a lot of fixes, and many new features. And I'm kind of like going through some of the proposals that have been done in the last month or so, and that had not been covered before in this venue, and kind of just like to give a glance of what the community is working on and what are the new features coming, and in a bit more deep. So one of the items was the proposal for the pool message consumption. The problem we tend to solve here was basically is that on the producer side, we have a very efficient way to send data, and we don't really need to copy the data. You can have the data in a byte buffer, for example, and that could be in a direct memory, and we will never allocate that memory into a heap buffer. And JVM heap buffer for payloads are bad because they will basically pollute all the Java heap space. And that means that the JVM GC has to be aware of these buffers and has to deal with them. So he has to many times copy them into an older generation, or he has to compact them. So it's a lot of work. And essentially, like every time you have these payloads, full payloads in the JVM heap, what happens is that depending on your throughput, you are going to have a lot more CPU, JC impact. Instead, we want to decouple that. We really want to take these byte arrays out of the JVM heap so that they're not managed by JVM, and just rely on direct memory, which is like manually managed. So the idea here is that we want to have the same functionality for consumers, but the current problem with consumers is that it doesn't provide a way to tell the library when you're done with the message. So sure, you can mark a message as acknowledged, but that just interact with the processing of the message. You might still try to access that memory after. So ideally, like we need to have we wanted to have a better way to signal the library that I'm really done with this message. I'm not going to touch it again, so that you can use that as a hint to reuse the resources. And the main goal here is to avoid copies of the data. So because right now we don't have that information, we have to make a copy of the data on the JVM heap, and the application will receive it. So by adding this extra step, we can avoid that. So just looking at an example is easier to explain. So if you look at this example, there is a new flag on the consumer creation that is pull messages. In this case, it's set to true, but by default it's false. And that means that the default behavior would still be the same one as before. If you enable these pull messages, essentially the application signals that I want this better throughput by having zero copy and message pooling. And I'm aware that I have to dispose of these messages. So whenever I'm done with the message, I have to release the message. If I use pull messages true and I don't release the message, basically that will cause memory leak in the system. So there's this extra step, which by default it's a good way to not have, because that we want to make it as simple as possible in the normal case. But by having this extra step, what means is that internally the byte buffer that we return on the message it doesn't have to be copied, because as long as the message is valid before it gets released, this data will be pointing to the same data that was received by the broker. So we don't have to make any copy of the data. So you use it in the most efficient way, and you get the message with zero copies, you process the message, and then you acknowledge, and then after that you can release the message. And the only thing is that once you call message release, you shouldn't touch that anymore, because that object and the memory it points to will be reused. So that really bring a new level of efficiency there. So it is not for everyone, but it's a good tool to have in the box, because for all the high throughput consumer cases, that helps a lot with reducing memory copies, allocation, the work on GC, and overall like the CPU usage, and really increase the throughput. So yes, there is one extra step, but it's really not that difficult to implement. Another one that is going out in 2.8 is the client memory limits. So this was already presented like last month. So we just go one example more. But the idea here is that we want to set a memory limit on the client instance, because in 2.7 right now, basically to set the memory limit, you have to do it through some proxy configuration. For example, you have to set the producer queue size in order to control how much memory that producer instance can use in the worst case. That is, it works, but it is not super easy to get it right. And the reason is that queues are like, there is one queue per partition, and the queue are based on the number of messages and not on their size. So depending on how big are your events, or like how many partitions you have, that could use a different kind of memory. So you might get surprises either on the wrong side by having auto memory errors in your client, or having surprises that the queue sizes are too small, in which case the throughput that you can push from that producer, it is impacted. So instead by having a client-wide, instance-wide memory limit, we just basically dictate that for this object, and that doesn't matter how many producers, doesn't matter how many partitions, I want to use up to this amount of memory, and doesn't matter how big my messages are. And that means also that right now we'll be able to disable the producer queue size. The producer queue size really was designed to do that, but by doing that by the client memory limit is a much better option. And I can show it here. So like instead of like by default using like 1,000 max pending messages, now we can turn it to 0. And that means that we're going to disable the limit on the max on the messaging queue instead we just rely on the other one, on memory limit. So I can create my client and saying that I'm gonna allow you to use 64 megabytes in the worst case. And when that memory limit is reached, then the pulsar will get either blocked or message will get rejected. So at this point, we don't need anymore the pulsar queue size, and we can set it to 0 to disable it. The point of this is that it will enable much higher throughput, because we're not going to get impacted by how many outstanding messages we have from one producer to the broker. Instead, we just like make sure that it doesn't, the amount of these messages across multiple producers will not exceed the 64 max, which is the better measure that really means what we care about, which is typically just the memory size. If you still care about the messages, then yes, you can set this to 1,000 or to some kind of like different number. But this will basically greatly simplify the tuning that you have to do to have like a high performance producer that would basically just boil down to this memory limit. You could increase that if you want to really have more outstanding data, but this is the idea. So for 2.8, this will be not set the default, but you can set them. And the idea is that once we are fully confident, then we can just change the defaults and have this memory limit 64 max to be the default value, and the pending max pending messages to 0 to be the default value in 2.9 release. So this one feature will actually not get into 2.8, but I think this is kind of like a good feature that gives a look on things that are happening in the community, and this gets released into 2.9. This feature is basically mean that we want to make sure that we have a better rate limiting that works across logical entities. So today you can set rate limiting both on the producer side or dispatcher side, and this gets applied on each partition. So if you set on this namespace, if you set a rate limiting of 50 megs for the traffic in, that actually means that each partition of topics that are in this namespace will get applied these 50 megabytes per second of limit. So it's not very intuitive, because you can just add more partitions or add more topics, and you can use more quotas. So instead, the idea here is to have a more logical way to define the rate limiting, and especially like to have them applied at the tenant or namespace level, or the partition topic level, and so that it makes more sense for an administrator to say that, okay, this tenant is allowed only, say, 200 megabytes per second. It doesn't matter how many topics it had. It doesn't matter how many namespaces it is using. It is only boxed into this. So technically, it is not trivial to do, because these topics are going to be served by different brokers. So there is no like it becomes a distributed system problem here, and we really went through and tried to think about like what was the most unintrusive way to implement this in a way that was like safe and not placing a lot of burdens on the broker, and be effective and at the rate limiting. So the configuration of this, the first part here is that we have introduced a new resource group. And this is a new entity. So a resource group is kind of like bridging topics, namespaces, tenants, and And the resource group, it is where the quota gets applied to. So I can create a resource group A, B, and C, and I can assign quotas to them. So I can say that resource group A has a quota of, say, 100 megabytes in, 200 megabytes out, and this much storage, say 1 terabyte of storage and nothing more. So whatever, and then different namespaces, tenants, and topic can be attached to this resource group. So an administrator can say that these tenants gets to be subjected to resource group A, and these are the tenants. So you can really mix and match. So there is no like dictated way to how to assign which resource group to a namespace. Someone might say, I want to create a new resource group for each tenant, or I want to create one and then attach namespaces to it, or and so on. Another ways would be to have a resource group for different tiers as well, so that if you are in the, and then put like all tenants that are in tier B on this resource group B, so that overall they get throttled by globally. So there are different ways that one can play with it. We chose to keep it flexible, so that it can be used in the most varied ways. And actually, I'm very personally curious on like what people like will want to use it. We had few ideas on how to do it, but we really want to see that validated, and more also like have suggestions on how people think about this rate limiting and how can the resource group configuration would be more sense for their use cases. But the important part here is that, so once you attach resources like a tenant or a namespace to a resource group, they will share the quota of that resource group. So it is not that everyone has the same configuration. Instead, they say that if I'm putting 2 namespaces on this resource group A, that means that they will compete for the same quotas. So if that resource group has 100 megabytes, then both namespaces will have to compete for that bandwidth. So finally, the resource groups, since are like a new resource, new entity, so they're managed independently. So they don't belong to either a tenant, namespace, or topic. Instead, there's a new concept in the REST API, which is resource groups, and you can create a new resource group, change the quotas dynamically, and change the association. Say that, okay, now that's this new namespace will be subjected to this resource group. And also, like there's the association that can be multiple, right? So a tenant can also belong to multiple resource groups, for example, and then if you get basically enforced by both. In the same way that you can also have a different level in a hierarchy. For example, you could have that the tenant is subjected to resource group A, and the namespace is subjected to resource group B. In that case, both will apply. So the traffic will be subjected to both quotas, and to get throttled accordingly. So regarding for how it is implemented, the enforcement of this, I will suggest to look through the PIP design doc, because that's very interesting, and there is like the full explanation on how this gets enforced. But just to give a quick idea here is that there's the concept of an internal topic. So each broker is responsible to report the usage traffic on the resource groups that are assigned to this broker. And essentially what we did is an implementation of the token bucket algorithm, but instead of like pre-acquiring the tokens, we acquire it after. And the reason for this is that since we are like doing a distributed enforcement of this quota, we want to make sure that we can fully utilize all the quotas and we can use it fairly. So if you have, say, for example, like a namespace with say 100 topics, and these topics are spread across, say, 5 brokers. Now, each of the 5 brokers will try to use the most of the quota. So if there is only one broker, this broker will basically allow these topics to go up to, say, 100 megabytes. Now, if a new broker comes up serving topics for this namespace, it will the quota is already taken. So this new broker will try to use a bit of that quota. And that will make the system overall to exceed the quota for a brief amount of time. And this is kind of like a design decision that is fine, because that will basically make it much easier to implement this distributed enforcement. So the new broker will be allowed to start with some quota, and depending on how much of this quota was actually used in the next iteration in a few seconds, that will basically readjust so that the first broker will actually have to step down and throttle, because it now it knows that it doesn't have the full 100 megabytes anymore. So it's kind of like this self-adjustment. And the idea also is that we always want to err on the side of limiting less instead of like limiting more. So we leave it to go over quota for a brief amount of time is fine, and we try to avoid going under quota, so that's throttling more than what the quota says. So that's kind of like the principle here. And just a few notes on the so that these were like kind of like a few items that are like actually being worked on. There are more, and this we go through in the two-rotate release for all of them in the more in depth, but just to give a glance of new cool features that we are implementing in the Pulsar project. Regarding the ecosystem, there are like a few updates here. So one is that there's been some discussion between the Pulsar community and the Presto Trino community. So Trino is one of the rebranding of Presto SQL. So the Trino community has been so there's been discussion between the Pulsar community and Trino community, and the consensus there is that we want to move the Pulsar SQL the connector into the Trino project, so that it can keep being developed and maintained there as a Trino plugin, instead of like being an adapter that lives in Pulsar. So this is really like moving the same code and make sure that because it's a better fit for that connector to live in the Trino repository and to be get maintained by that community, since they have connectors for all varieties of systems. So this is going to happen in the next weeks, and we are looking forward to it. Another one that at StreamNative we have open source function mesh. So function mesh is actually kind of like an addition to Pulsar function. It's kind of like a different way to look at Pulsar functions if you want. The idea is that you want to ease the management of running multiple connected functions and connectors. So one of the problems is, so functions are reading from one topic and writing on a topic, and there is no like orchestration of multiple functions. So if you want to have like a bit more complex kind of like topology of data processing, you can stitch them together, but for Pulsar function perspective, they're kind of independent. So they're independent functions. So the function mesh is adding two things. So one is a declarative way of defining your mesh and your topology, and you can declare and and submit that to the cluster. And you can mix connectors and functions. So you can have a source connector that gets data in from a variety of the Pulsar IO sources, and then having different functions to process that data in different ways and routing, and then have the data gone to a sink so that it can get published in a different system. So all of these can be declared in the function mesh definition. And if you look more at the at the architecture of the function mesh, is that it is really built for Kubernetes, and it provides an API there. So, and then you can basically use that to control the function mesh operator. So it also changes the way that functions are scheduled, in that it is not anymore by the Pulsar function worker. Instead, it is the function mesh operator that takes care of it. So it's kind of like a better way to define your function mesh, and at the same time also a better way to run it, because the operator can do more sophisticated things than the Pulsar function worker with the Kubernetes runtime. So these are open source have been open sourced by StreamNative, so you can try it out and see. On the StreamNative Cloud side, there was a new announcement a couple of weeks back that was around the Flink SQL. So Flink SQL, it is now supported on the StreamNative Cloud, and really what you can do with this is that in your cloud cluster, you can enable that on the, and once it is enabled, you can submit SQL queries and see the result in real time on the UI. So if you look at the way it works, is that from the backend perspective here, when the query is submitted by the UI, it will use the SQL gateway, and it will do an interactive query on the Flink cluster. So that will basically generate this Flink job that will go and fetch data from Pulsar, and using, so all the schema is integrated. So the query will be able to retrieve all the data and do your SQL query and present all the result in the cloud console in the native control plane. So this is just one other way in which the Flink and Pulsar are kind of like a really there's very good integration between the two projects, and that's really what meaning like a cloud native streaming platform and for infinite data streams. So it's not just like a slogan here, but I think it's really true, because if you combine all these features with the power of having the data stored for extended amount of time, or like infinite time, with the tier storage in Pulsar, that gives like a lot of flexibility and power in querying that data in different ways. But it is the same data that's stored once, and you can really use different tools and different ways to access that data in the best way that makes sense for you. And on the like reminder, so that there is also like the office hours. The next one is on May 19th. So Edson will do that. So it's 12 p.m. Pacific time, and you can join and ask all the questions. They are live. For the upcoming event, so this multi-project update is every month on the second Wednesday, and the office hours are every month on the third Wednesday, always at 12 p.m. And there is also like the Into the Pulsar, which is on the every third Wednesday. So and with it, I'm concluding this the session for this month. If there is any questions on the project updates, I'm very happy to respond to that on the just ping me on the Slack, on the Pulsar Slack, and I'm happy to talk about any of these features or like upcoming things, or when the releases are due and so on. So just thank everyone.